Hey friends. Okay, grab your coffee and come hang out with me for a bit. I've got something wild to share with you. So here's what blows my mind. In healthcare, we use something once and then what happens? We throw it away. Just toss it. Done. Every single day, all day long. But wait, what if some of this stuff didn't actually have to be disposable? Today, let's dive into reusable circuits, what they are, why they matter, and how small changes like this can make a surprisingly big impact. We are healing patients, but are we really healing patients or causing harm?
It's a massive contradiction, isn't it? You have this space that's dedicated to healing that is at the same time just generating a staggering amount of pollution.
The numbers are wild. I mean, operating rooms consume something like 3 to 6 times more energy per square foot than the rest of the hospital.
Huge energy sinks.
But the one that really stuck out to me was the waste. This one department, which takes up a pretty small physical footprint, is churning out up to a third of a hospital's total waste.
And a huge portion of that is what we call complex waste. So it's not just office paper. It's biohazard materials, it's mixed plastics, things that are incredibly difficult and expensive to process.
Which brings us to the stack of research we're diving into today. We're zooming in on one specific culprit in that waste stream. It's the anesthesia breathing circuit.
Ah, yes.
I've got the technical diagrams here, and honestly, calling it a tube feels like a total disservice. This thing is a complex piece of engineering.
It is. It's essentially an artificial lung.
hmm
This is the lifeline that connects the patient to the anesthesia machine. It's doing all the heavy lifting, delivering oxygen, delivering anesthetic gas, scrubbing out carbon dioxide.
Yeah.
It has to be airtight, it has to be durable, and it has to be precise.
And you've got the inspiratory and expiratory limbs, all this intricate tubing, but then there's so much more. Eye connectors, directional valves, filters, and the reservoir bag.
That balloon-like component, you see them squeezing.
Yeah. It's a lot of high-grade medical plastic.
It is. And in the United States specifically, the standard operating procedure is to take that entire complex assembly, valves, tubing, bag, all of it,
hmm
use it for maybe 45 minutes on one patient, and then throw the entire thing in the trash.
And that is the status quo we need to talk about. Because we have this new study. It's from late 2025 that suggests this whole single-use mindset is not just wasteful, it's actually financially irresponsible.
The Quay study. Right. They did something really smart here. They didn't just look at general surgery, they looked at electroconvulsive therapy, or ECT.
Oh, because those are really short cases, right? High turnover.
Exactly. An ECT procedure might only take, what, 10 or 15 minutes? So if you're changing the entire plastic circuit between every single case, you are generating a mountain of waste by lunchtime. It creates a perfect laboratory to measure the impact of disposables versus reusables.
Okay, so let's look at their results because the difference here is significant. They compared the standard single-use workflow against a reusable one. And the physical waste generated per case drops from over 350 grams down to just 99 grams.
That is a massive reduction in physical mass.
It's almost 75%.
And that correlates directly to greenhouse gas emissions, which they found dropped by roughly 50%. But what usually catches the eye of hospital administrators is the cost line,
Right, because usually going green comes with a green premium. You expect it to cost more.
of course.
But Quay's data shows a 40% reduction in median per case expenditure. They went from spending about $8.50 per patient down to $4.30.
And that 430 figure includes the cost of sterilization, which is a crucial detail.
Right.
We aren't just comparing the purchase price of the plastic, we're comparing the full life cycle cost.
So on the surface, you have a solution that is cheaper, it's greener, it creates less garbage. The obvious question is, why is the single-use circuit still the dominant model in the US?
It comes down to what we often call the yuck factor.
Infection control.
Right. It's the visceral fear of cross-contamination. You know, if I use this tubing on patient A and then patient B comes in an hour later, am I exposing patient B to patient A's pathogens? It's a valid clinical concern.
But this is where the technology has evolved. I was watching this workflow video about this setup at Lucille Packard Children's Hospital, and the key seems to be how they compartmentalize the equipment. They split it into a machine kit and a patient kit.
That distinction is vital. The machine kit is the long corrugated tubing, the bag, that stays attached to the machine. It doesn't touch the patient directly. Then you have the patient kit. This is the only part that's single use. It consists of the mask, an elbow connector, and most importantly, the filter, the HMEF.
Let's get into the weeds on the filter, because this is the piece that makes the whole system work. In some of the Reddit threads we looked at, there was a lot of skepticism. Doctors asking, can a filter really stop a virus?
Well, the answer lies in the physics of the filter.
Mm-hmm.
We aren't just talking about a screen door that keeps out flies. These are typically hydrophobic, pleated, mechanical filters.
Hydrophobic, meaning they repel water.
Exactly. They stop liquid penetration, which is the primary vector for bacterial and viral transmission in this context. But they also trap airborne particulates down to a viral size.
There was that anecdote in the Reddit thread, the coffee test. A sales rep apparently poured a cup of coffee into the circuit.
Ah, yes. To demonstrate that the liquid couldn't pass through the filter, it's a great piece of theater.
But it makes the point.
It does. If the filter can hold back a cup of coffee, it's certainly going to stop the moisture from a patient's breath. But, while coffee sounds are fun, we need to rely on the clinical evidence.
Which we have. One of the studies and the guidelines from ASRI Pain Medicine were pretty definitive. They found no reported cases of iatrogenic infection linked to reusable circuits when a high-quality filter is used.
Iatrogenic being the key word there, meaning an infection caused by the medical treatment itself. The data just doesn't support the fear. In fact, these filters have a retention rate of 99.999% for bacteria and viruses.
So statistically, you are safer behind that filter than you are in most public spaces.
Precisely. And we have long-term data to back this up. The report from the Ontario anesthesiologist mentions North York General Hospital. They haven't just been doing this for a month. They've been using reusable circuits for nearly 20 years.
20 years. That's a long time to run a dangerous experiment if it was actually dangerous.
If people were getting sick, we would absolutely know by now. We'd see the signal in the infection control data. We haven't.
So if the science is solid and the economics are favorable, why do we see such a massive divide between the U.S. and, say, Europe?
It's a stark cultural split. In Germany, the UK, Ireland, the standard practice is to change the circuit weekly.
Yeah.
You come in on Monday, set up the machine, and just change the filter for each patient. The tubing stays.
Whereas in the U.S., if you suggest reusing a tube, people look at you like you're suggesting reusing a syringe.
There is a heavy defensive medicine culture in the U.S. There's a perception, however incorrect, that single use is inherently safer and therefore protects the hospital from liability.
Could cover your ass mentality.
Basically, if you throw it away, no one can sue you for not cleaning it properly. Plus, it's just easier to rip open a bag.
But there was a user on that Reddit thread who made this argument that I thought just it completely dismantled that logic. They called it the ad absurdum argument.
I know exactly the point you're referring to. It's a logic check regarding the machine itself.
Right. They pointed out that the anesthesia machine isn't a solid block. It has internal valves, bellows, sensors, and those parts are never sterilized between patients.
Exactly. The breath goes through the tube, but it also goes into the machine's bellows to be pushed back out. Those internal components are not sterile.
So the only thing protecting the patient from the dirty inside of the machine is
The filter.
the filter. So the logic is, if you trust the filter enough to protect the patient from the unsterile machine, why don't you trust that same filter to protect the patient from the plastic tube attached to it?
It exposes the inconsistency. The plastic tube is just an extension of the machine. If the filter works, it works for both. If it fails, the patient is exposed to the machine's internals anyway, so a fresh tube wouldn't save them.
That's the aha moment for me. Throwing away the tube is essentially performative hygiene.
It is.
Right. There's also the logistical barrier, right? You can't just decide to switch to reusables on a Tuesday. You need a system.
You need a staff who are trained to reassemble everything correctly.
And however, there's an argument to the logistical headache, and it comes from a supply chain perspective.
Resilience.
Yeah. When the global supply chain freezes up, like we all saw during the pandemic, hospitals that rely on single-use plastics are incredibly vulnerable.
That is the hidden strategic value of reuse. If you rely on a shipment of plastic tubes from overseas every week to keep your OR open,
It changes the conversation from just saving the planet to securing the hospital.
it does. And once you start pulling at this thread, you realize the circuit is just one piece of the puzzle. There's so much low-hanging fruit for greening the OR.
We have to talk about the gas itself. I was reading about desflurane versus sevoflurane, and I had no idea there was such a massive difference in their carbon footprint.
It's huge. Deflurane is a climate supervillain. It has more than 20 times the global warming potential of sevoflurane.
20 times?
Yes. And clinically, they do very similar things. So an anesthesiologist can reduce their carbon footprint by 95% just by turning a different dial on the machine.
That seems like the definition of a no-brainer.
No new equipment, no washing protocols, just a choice of gas.
And then you have the carrier gases. A lot of procedures use nitrous oxide, laughing gas.
Which is an ozone depleter and a greenhouse gas. Switching to air or plain oxygen as the carrier gas just eliminates that impact entirely.
And then there's the blue wrap. I feel like anyone who has walked past a hospital loading dock has seen bags and bags full of that blue, sterile paper.
It's everywhere. It accounts for nearly 20% of OR waste. And again, there's a reusable solution. Rigid, hard cases. Think of them like metal lunchboxes for surgical instruments.
And the data shows that cuts emissions in half over 10 years compared to the wrap.
Right. So when you combine all these things, reusable circuits, better gases, LED lighting, rigid containers, you aren't just making a marginal difference. You are fundamentally changing the ecological footprint of healthcare.
So bringing this all back to the anesthesia circuit, it seems like the technology is there, the filters work, the physics holds up,
The safety data, 20 years of it holds up.
and the economics, generally speaking, hold up.
They do.
So the barrier isn't scientific. It's psychological and it's logistical.
It is. It's about shifting from a culture of convenience where clean equals new to a culture of stewardship. It requires hospitals to stop looking at waste as an inevitable byproduct and start seeing it as a design flaw.
It really forces us to broaden the definition of the Hippocratic Oath, doesn't it? Do no harm.
That's the question I leave with people. If we are saving a patient in the OR, but we are damaging the environment that that patient has to live in for the rest of their life, are we fully upholding that oath?
If we use a plastic tube for 45 minutes that is designed to last a year, and we bury it in a landfill because we're afraid of a risk that the data says doesn't exist, it feels less like safety and more like negligence.
I would agree. It's a challenge to the medical community to align their environmental practice with their clinical excellence.
Well, that is plenty to chew on. Next time you're in a hospital, hopefully just visiting, you might look at those machines a little differently.
Thanks for listening.